Welcome back to our series on rational functions. Today we're going to talk about a point of discontinuity in the graph called a hole. In previous videos, we've talked about undefined points or discontinuous points in graphs, and that those occur when we have the bottom, the denominator of the rational function equals 0. We also talked about vertical asymptotes, which is where one of those factors on the bottom does not cancel with a factor on the top. Today we're going to talk about another type of discontinuity called a hole. And what does that look like in a graph? Well, when we have a rational function, we a lot of times end up with some horizontal asymptotes and some vertical asymptotes, and our function a lot of times approaches those. Don't have a very straight line there, but that's okay. But sometimes when we're going along in the rational function, you'll have a random point that just doesn't work. And then it keeps going on after that. All the points around that point work, but that point specifically doesn't work. This one looks like it might be at about -2, -4. So we would say we have a hole in this graph at -2, -4. How do we find those from the function? Well, the first function we're going to look at is y equals 2x plus 2 over x squared minus 7x minus 8. Let's go ahead and factor that first. You can pause the video and factor this. So when we factor it, we end up with 2 times x plus 1 over x minus 8 times x plus 1. And you notice we have a factor on the top and the bottom that's going to cancel. X plus 1 and x plus 1. What's going to happen is we're going to have a hole where x plus 1 equals 0. Well, where does x plus 1 equal 0? Well, it would equal 0 and -1. So our hole is going to have an x value of -1. What's the y value? Well, we find that by using our new function. Now that we've canceled x plus 1, we're left with the function 2 over x minus 8. Well, let's go ahead and plug in that -1 for x. We would get 2 over -1 minus 8, which is going to give me the y value of that hole, -2/9. Whenever you're doing these, you need to make sure you plug that x value back in. Some common mistake for these type of problems is to find the x value, but then forget to plug it back in to find the y value of the hole. Let's try another problem. Y equals x squared plus 5x over x cubed plus 12x squared plus 35x. Go ahead and pause the video and completely factor that. When you do factor that, you're going to end up with x times x plus 5. And this bottom one actually factors into 3 parts. First, we can factor out the x, but then what we're left with factors into x plus 7 and x plus 5. Now notice here there's actually 2 factors that we have in common. The x's are going to cancel, and the x plus 5's are going to cancel. This means we're going to have 2 holes. One where x equals 0, and one where x plus 5 equals 0. So our holes, we're going to have one at 0 something and one at -5 something. Let's go ahead and write out our simplified function. What are we left with on the top? What could I put there? What can I always multiply by and not change anything? Well, it's a 1. X plus 5, and we're just left with 1 over x plus 7. So we've got y equals 1 over x plus 7, and we need to plug 0 in to find the y value of that hole, 1/7. And we need to plug -5 in to find the y value of that hole, which would be 1/2. So when we graph this function, we don't know exactly what it's going to look like yet, but we do know at -5, 1/2, -5, about 1/2, and at 0, 1/7, really close to the axis, we are going to have two holes in the graph. Let's take a look at one more problem. Y equals x squared minus 16 over x squared plus 10x plus 16. Go ahead and pause the video and factor. We're going to end up with x minus 4, x plus 4, and on the bottom we actually have x plus 8, x plus 2. This would be an instance where even though both the top and the bottom factor, there are no holes in the graph. So let's go ahead and summarize what we've learned in this video. A hole occurs when a factor on the top and a factor of the graph on the bottom cancel. And a hole is always an ordered pair. You need both an x and a y value. In the next video, we're going to take a look at horizontal asymptotes, and then we will be getting close to being ready to graph these functions.